Okay, hi, a very good day to you. And today we're going to start with our elementary math, chapter 3 on indices. Alright, so what is actually indices, right? Indices, or what we call index notation, is what you've seen all the way back in Sec 1 already, especially when you're doing your prime factorization, where you write down a number and a power over that. Right, so this is our index notation, and today we're going to explore a little bit more about the index notation, and we're going to look at what are some basic rules that we can use to help us to simplify and make our life easy when we want to when we want to evaluate certain things. Okay, so first and foremost, let us take a look at what is the meaning of an index. All right, for usually for singular we call it index. The plural form is indices. Okay, so for example, let's take a look at this example over here. Alright, we have our 5 to the power of 4. Alright, so over here you can see that 5 is the base, alright, and 4 is our index. So this one you must know, okay, this will be the language that we'll be using throughout this chapter, right? 5 is the base, 4 is the index. And what does this mean? It means 5 times 5 times 5 times 5. It will be 4 times, alright? So actually, right, these indices, it actually gives us a very smooth way, an easy way to write down repeated multiplication. So for example, it is just an extension of what we've been doing always. For example, let's say last time we have 5 times 4, which actually means 5 plus 5 plus 5 plus 5, right? 4 groups of 5. Okay, for index, it is just 5 times 5 times 5, so it's just a repeated multiplication. Just as you know, when we talk about this, it is a repeated addition. Okay, now, so in general, right, whenever we say that we have something, right, a number base a raised to the power of n, this means that we are referring to a times a times a times a all the way, and this will last n times. Alright, this will repeat, and we will repeat this process n times to get our a to the power of n. Okay, so this is the general index notation for just one number. Okay, and of course, as you can see in prime factorization, there are numbers such as like this. So 2 raised to the power of 4 times 3 square times 5 to the power of 1, and so on and so forth. Okay, so for this kind of thing is also in index notation, but with multiple bases together. Okay, the bases are 2, 3, 5. The indexes are 4, 2, 1, the respective index. Okay, so next we're going to look at some laws of indices. Now, for this part, right, it may feel overwhelming, okay, but I encourage you to not just take these laws and memorize them, but really understand what is really going about in these laws. Okay, so over here we have 5 basic laws of indices, and we are going to make use of these laws again and again and again and again. Okay, so so this part will be the foundation of what we will be doing for the rest of the chapter. Okay, so let's take a look at the 5 laws over here on my left. Okay, and we are going to focus on the first two over here. Alright, so what are these laws actually? I like to call them so these 2 laws, right, is actually our same base laws. Okay, as you can notice, right, all these numbers, right, they have the same base, right? They are of base a. So when you have a base a to the power of m multiplied by base a to the power of n, okay, so when you multiply them together, you can add the power over here, m plus n, right? Same thing over there. If you look at a to the power of m divided by a to the power of n, what it means that because they have the same base, we can combine the powers together, combine the indices together, and we will have our m minus n as the index. Okay, now let's take a look at why do we do this. Okay, without further ado, it will be good to flip to your textbook, right, all the way to page 53, right, 53 over here, and we are going to look at, you know, the investigation part. okay, of our laws of indices. So in the textbook, right, over here you have your 7. Okay, the first example over here. Now let's explore a bit. Now we have 7 squared times 7 power 4 raised to the power of 4, and when you combine them together, right, it's actually 7 to the power of 6. But why? Because 7 squared, we can write this as 7 times 7. 7 raised to the 4th power, we can write it as 7 times 7 times 7 times 7. Total of 4 factors over there. Okay? And with this one, right, when we combine them, because like we are all doing multiplication, it's just all the same thing, so we just combine them together, 6 factors. So it is 7 to the power of 6, which is also equivalent to 7 to the power of 2 plus 4. So we can add the powers together, right? Okay, let's take a look at number 2 over there. Alright, same thing over there. It should work for negative numbers as well. Okay, so the first one, negative 6 to the power of 5, we will have our negative 6 times, okay, I'm not going to use like that times because it's a bit distracting from the x that we will see in the future. But over here we have negative 6 5 times, 5 factors, and we have a negative 6 3 factors at the right hand side. Because this is negative 6 to the power of 3, we have 3 factors over here. So in total, how many factors do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 of them. So over here, we can simplify it to negative 6 raised to the 8th power of 8. And it is also equivalent to negative 6 to the power of 5 plus 3. Okay, so what we can do is we can add the powers together, 5 plus 3 to give you the 8. Okay, so all together over here, if you want to do it yourself, you can. I'm just going to like skip a few steps and let us predict the future. So over here, when we have a to the power of 3 and a to the power of 4, in total we should have 7 factors, correct? 3 times 3 of a and 4 of a, all together 7 of a, and we have a to the power of 7, which is also same as 3 plus 4. So in general, okay, in general, if you want to go to a to the power of m times a to the power of n, we have m of a at the first one, and then we have n of a at the second one. So all together we have your m mango plus n nectarine. So mango, nectarine, all together m plus n. Okay, so we can add our indices together. Okay, so when we multiply, the index add together. Okay, I'm going to move on a bit to the practice now 1. Okay, let us take a look at some examples over here, and let me get rid of this annoying thing for a while. Okay, alright, so let's come back to this. So practice now 1 at the next page. Okay, let us try and see what is going on over here. So we have 7 squared and 7 to the power of 5. So we can simplify. Okay, so what we are going to do is we are going to simplify each of these. Okay, and we leave our number in index notation. Means we don't have to evaluate the final value. We just need to leave the answer in index notation. This one is suitable for us to assess and see like how with the different bases, how the powers combine. Okay, so over here, let's take a look at A. We have 7 squared, 7 power 5. So 7 squared and 7 power 5, same base, 7, 7. So we can mash them together. So 7 to the power of 2 plus 5. So 2 plus 5 would be 7. So 7 to the power of 7. Okay, part B. We have negative 3 as a base, power 5 and power 1. We can mash them together, add them together. So negative 3 to the power of 6. Next one. A to the power of 12, a to the power of 8. So without further ado, it will be a to the power of 12 plus 8, because same base a. And then we have a to the power of 20. Right? Last but not least, alright, for D, we are going to pay attention for this kind of question, because D is the one where it is a little bit more complex, and usually, like, you know, it will be a little bit more creative to test lah. Okay, so for this one, yes, so how are we going to simplify this? So my strategy is I'm going to get all the numbers together, all the coefficients together, and I'm going to get all my bases together, and I will do that in a very organized way. So that is a strategy to handle questions like D. Okay, so first and foremost, we have our 2 times 3, correct? So 2 times 3 is 6. Next, I will have my x, and x on the left, okay, if they didn't write anything, right, it is x to the power of 1. Okay, so we have x power 1 and x power 5, same base, let's mash them together, x power 1 and 5, so it will be a power of 1 plus 5. And y, okay, we have our y to the power of 4 and y to the power of 3, multiply together, we have y to the power of 4 plus 3. Okay, so let's simplify the index. We have 6x to the power of 6, y to the power of 7. Of course, you can do this straight away, but I'm doing it step by step so that you know, for those that really need it, then yeah, we can understand better. But definitely, if you can see it, why not go straight over here? Okay, so this is law 1, the addition law, where we can where you have the same base and it's multiplied, you add the index. Okay, law number 2. Let us investigate law number 2. Now, instead of multiply, we have our divide over here. Okay, so let's take a look. We have 5 to the power of 7 listed on top. We have 5 to the power of 3. We can list them below. Okay, 5 to the power of 3. We can list them below. So when we divide, right, we can actually express them as a fraction. And like primary school and like maybe sec 1, sec 2, when we see fractions, same factors, what do? We can usually cancel. So we will, okay, this is rather big. Okay, we will cancel. Okay, so overall we will, okay, on the bottom we have 3 factors. So overall, how many of 5s do we have left? We have 5 to the power of 4. We have 4 of them left. So this is actually equivalent to 7 minus 3. Okay, 7 minus 3, you get your power 4. Okay, so the cancelling, right, is as if you minus the index. Okay, let us take a look at negative numbers as well. We have negative 10 to the power of 5 and negative 10 square. So at the bottom we have negative 10 times negative 10. We have 2 factors over here. So how are we going to like cancel? We can cancel 1 by 1 like that. Okay, so just nice, we have 3 of the same bases together, so it is equivalent to 5 minus 2 to have 3 of them at the end. Okay, now let's take a look at the next page, next question. Now if a is not 0, then a to the power of 9 divided by a power 4. Now over here, let me write down first, I have 4 a's at the bottom because a power 4, I have 4 factors over there. Now why did they state the condition if a cannot be 0? Now if a is 0, 0 over 0 would be a very big math error, correct? It is undefined. Okay, so there's no such value when you take 0 divided by 0. Okay, so whenever we do this, whenever we take unknowns, whenever we take unknowns at the denominator, the variable or the unknowns will not be 0 usually. Okay, so that aside, let us focus back onto the law. So the law is cancel 2, 3, 4, cancel 2, 3, 4, 4 of them. So we have 5 left, so it's a to the power of 5. So it is the same as a power 9 minus 4. Okay, so the overall effect is, okay, when you have m factors on top and n factors below, you are going to get the difference of the factors. So the power would be a to the power of m minus n. Okay, so just now, we take a look. So we have a to the power of m times a to the power of n. Same base, when you multiply, the powers will add, the powers will sum up. Now is same base but divide, the power will minus, so you have the difference of the powers. Okay, so this is the difference between law 1 and law 2, but both work together, same base. Okay, so okay, let us ignore questions 5 and 6. We'll answer those questions later in the second part of the thing. Now let us come to practice now 2. Let us solve some questions over here. Okay, so we have okay, a 9 to the power of 7 divide by 9 to the power of 3, same base, so I'm going to combine them as 1. Divide means power minus power, so I have 7 minus 3, so I have 9 to the power of 4. Okay, next one. Negative 4 to the power of 8 divided by negative 4. So same base, I will have the same base, and it will be 8 minus 1 because divide. So I have negative 4 to the power of 7. Okay, C. A10 divided by A6. So we have our A as the same base. So power 10 minus power 6. So A to the power of 4. Last but not least, okay, so this one is the one where it is a bit intimidating, but don't worry too much, okay? You've probably seen this in Sec 2 where you do the active cancelling, you know, like cancel the 6, cancel the 3, that kind of thing, and then you find the remainder, okay? Now, so you can do that for this part, but I want to propose another way of writing this in a very neat fashion, which is what we did just now with practice now 1D, the earlier example. So I'm going to like do this together. So so the numbers on top, 27 x power 9 y power 4 divided by 9 x power 6 y power 3. So what we have over there is 27 divided by 9 is going to be 3. Okay, then x power 9 divided by x power 6, we have x power of 9 minus 6. Then on top we have y power 4, below we have y power 3. So y power 4 divided by y power 3. So we have y to the power of 4 minus 3. So let us simplify the powers. 3x to the power of 3 and y to the power of 1. So we just don't put the 1 there. Okay, it's understood lah. Okay, as y1. Okay, so this is our difference. Okay, the difference. Okay, the law 2, the dividing one. Okay, so at this point, if you feel like taking a break, feel free to take a break. I'm gonna go on and settle all the other laws, okay, in this in the 5 laws. So stay tuned. Okay, in the next video you will see law 3 in action and law 4 and law 5. Okay, so that's all for this video. We'll see you in the next part.